Okay, today we're going to go into the wonderful world of 1-8. Now, just to give you guys a heads up, today we're going to cover 1-8. Tomorrow, Mr. Castano is going to come in and talk to you guys. We won't have a math lesson tomorrow. He's going to come in and kind of talk to you about high school and what to expect, even though we pressured it on this last week. But he usually tries to knock it out early. So he's going to come in tomorrow, talk to you about things to expect, things that you need to worry about, things like that. So we won't do a math lesson tomorrow. Wednesday, we will review Chapter 1, which means Thursday we'll take the Chapter 1 exam. Okay, so this is the last section in Chapter 1 today. So, let's go. A couple things real quick. You everyone got out your journals, right? All right. I'm just gonna hit on this just briefly. Don't write this down yet. If I have, forget it. I'm going up here. Sorry, people. If you're watching, I'm up here on my board. If I have a graph that goes like this. Okay. Who could tell me my x-intercepts? Raise your head if someone could tell me where Maddox go. 1, 2, 3, 4, 5. So -5 and what? Right? Well, it goes through right there, so 0, right? So that would be that intercept. What about this one? What would this one be? Not 1. 1, 2. So 0, -1 would be that one. Right? That would be a y-intercept, right? What would this say? Oh, sorry. I know you guys are saying I said x, didn't I? So my two x-intercepts would be -5 and 1, and my y-intercept would be -2, correct? All right, any questions on that? This is something, I'm not going to spend any more time on this because this is something you guys should be extremely familiar with already. So the first part of today is just going to be finding x and y intercepts. That's extremely easy. Now we're going to get onto the stuff that we're going to talk about. So, journals out. I'm not going to have you write down this entire table. So there's a huge table I'm going to show you. But I'm going to tell you which one I want you to write down. So everyone pay real close attention to this. Everyone ready? So there's a part of this table I want you guys to write down. And the part that we're going to write down is, look at this, how close can I get? Look at that, that right there. Now, I want you to write down a function is increasing and decreasing.
What's the title?
Title it behavior of graphs. Or reading graphs, either one, I don't mind. I don't know what I'm supposed to do under the COVID rules.
I never jumped the
All right, everyone, come here. Can you hear me? Hey, stay together. Top parking lot. Top parking lot. Top parking lot, Carl. We can put your phone back. Top parking lot. Everyone remain calm.
Students, stay in class. It's all clear.
Hold on.
Custodian set that up. You can return to your classroom. All clear.
But losers also
That was beneficial.
That was actually good though. If that was a real fire, we were set.
Nathan, I didn't even leave the classroom.
You started.
We would have survived that fire, guys. Good job.
Custodian started the fire.
We did.
JT.
Can the custodian be named Brian for today? Good job,
I
Brian.
need you to slow the spread of the fire. Okay, keep running. Make sure you draw the picture.
I would like to watch that video and hear what happened.
Which video?
This video and hear everyone freaking out.
Oh yeah, that might be good actually. We'll pull it up on YouTube at the very end.
You gotta Photoshop it so
All clear,
it's just like.
just the alarm set up, nice and workers.
I am sorry for you guys that are watching this video. That was a fire alarm.
Later with you, excuse Jackson Middle, please.
Yep.
Thank you.
Jackson, report to the principal's office immediately. Jackson Redmond from the principal's office. You are dead.
You should put like a headphone warning before the fire alarm.
Or just cut it out.
That actually hurt my ears
Yeah, that
really bad.
scared me.
I had no idea. It's always that loud though. God, that hurt.
It's even louder in the hall.
I feel bad for the Apri and Maddox back there right underneath it. Hey, last year we did it, and there was a student that fell completely out of her chair. They make it like as loud as possible, that stupid fire alarm.
Maybe you guys look up and watch.
When I attended SUU, I set off the smoke. I set off the smoke alarm, the fire alarm, in the lab. That same lab I was over. I was in there. We were doing this combustion test, but there's like this special hood thing that we're supposed to do it in because it has a ventilation system. And I'd done it like 25 times and never had any issues. So I just, oh my God, just knock it out on the table so we can get it done quicker. My lab partner I was working with was a first-year biology student. And I told him anyways, there was a certain mixture, there was a certain grams of sulfur dioxide he had to put into it, magnesium dioxide. And he dumped almost 3 times the normal amount into it, and it just started spewing smoke. Smoke alarm, fire alarms going off, people are running out of there thinking they're gonna die. People are trapped down in the cadaver lab with the dead bodies. It was a terrible scenario. Okay, increasing and decreasing. First off, it's very important you understand this. Graphs are read. They can't hear me. Graphs are read left to right. Funny quote. Graphs are read left to right. So in this example here, as you guys can see here, the red lines are decreasing because from left to right, they're going down. From left to right, they're going down. The blue lines are increasing because from left to right, those are increasing. Does that make sense? So graphs are always read left to right, no matter what the circumstance is. Okay, questions on that? So from left to right, if it's going up, it's increasing. There is a situation where you might see something like this. You might see a flat line. So for example, you may see a graph. So if this is my graph right here, we may see a line that comes down, which would be decreasing, right? And then we may see a line that turns like this. What would that flat line be called? Anybody know? What's another word for not moving or staying steady? It's constant. So constant is flat. So we have decreasing constant, and increasing right there. Does that make sense? Okay, the last little bit of this. So one of the biggest things on the ACT test you guys will have to take is they give you graphs and they say interpret this graph. So for example, they're going to say something like this. So they're going to give you a okay, so it says that Frank rides his bike at a constant speed. So if we look at this, and I know this is really hard to see. Why is it so hard to see? What I need to do is I need to print it off. Give me a sec. Give me just 2 seconds. I'm going to print it off and show you underneath my thing so we can see it better. Here. Britton, what's your favorite Disney character?
Cinderella.
I'm asking Britton. Cinderella. There's a lot of them.
Hold on. I don't even know.
What about? Anna, who's your favorite Disney character? You guys suck.
I just like the Lorax. That's what Disney is.
No, he's not Disney. Okay. Okay, so these graphs are going to describe situations. So, here we go. The Lorax is Anna, you're fired.
No, I knew it wasn't Disney.
You're fired! Okay. Is that any better? Alright. So it says Isabel drives at a constant speed for a while. So the first thing you have to realize, so we're just dealing with these top 4 graphs and we're trying to determine which one is correct. So it says Isabel drives at a constant speed for a while. And then it says which one of these graphs it demonstrates what she is doing. So Isabel's speed right here is a flat line. Which one would this one be? What is Isabel's speed decreasing? Is she decreasing?
Yeah.
This one's increasing. This one's rocket ship. I don't know. So what would be the answer to this one? Yeah, the first one, right? Okay. John walks home from school. So look at the y-axis. It says John's distance from home. So if we're thinking about it, if we talk, so in this case here, we'll say that 0, as he's working closer to x, it'd be home. So which one of these gets closer to x? Yeah, this one right here, right? So look, this says that he started at school and he's walking towards it, right? He's walking back towards home. Now, why would I call 0 home? Because 0, 0 is kind of the origin. It's kind of home, yeah? What do you think? Walks from home to school. Yeah, it'd be this one. I didn't read it. Good, thank you, Maddox. So it'd be this one. It's not this one. So he's walking from home to school. So he's going away from his home. I seriously stopped reading. For some reason I said John walks to home from school. What's that called when you mix up words? Never had that before. That's new. Alright, so let's look at this one. Charlie stays in New York instead of flying to Texas. So which one of these is a steady distance away from to Texas? Second one, right? This one we're not doing a rocket ship.
But it says flying.
You're right, but still they take off like this, right? And he doesn't fly. Stays in New York instead of flying. If it's no. Okay? At the end of a race, a runner slows down. A, B, C, or D? D, right? Their speed is getting slower. Okay? Look at these. These are so much fun when you read them right. Here we go. Donna bikes from home to work. So which one is getting farther away from 0? Not rocket ship. Which one of these is, it's A definitely, right? Because she's going from home to work. Alright, a plane speeds up before takeoff. Which one? What do you think?
She's going to work.
So Donna's distance to work, so it'd be this one.
But that's helicopter.
So these are kind of hard. You have to really read these right here. That one's actually kind of a tricky one. So it says Donna bikes from home. Check this. Donna bikes from home to work. And then the y-axis is Donna's distance to work. So what we're saying here is that as she's going this way, this would actually be getting farther away from work. So you have to kind of think of it like that. So it'd actually be this one. Thank you, Nathan.
Why?
Because the y-axis, it's not saying Donna's distance from home. It's saying Donna's distance to work. So it's just kind of tricky right there. That one's I don't like that one at all. I like them all except for that one so far. So hopefully they don't give you one like that. A plane speeds up before takeoff. What would this one be? It'd definitely be that one, right? Speeds up. Plane speed increases. Okay. Those are the easy ones. Except for that one. Donna. Donna, screw you. Okay. These ones get a little bit harder. So check out this one. It says that Dion is hiking toward his campsite at a constant pace. A few miles from his campsite, he sees a snake and turns and runs the other way. Minutes later, he rests for a while. Okay, so we got to think here. First thing is he's walking towards his campsite at a constant pace. So we got to be walking towards his campsite. So I guess there's only one choice there, right? Because all the other ones are walking. This one's staying constant away. This one's leaving campsite. And this one's, I mean, if you just read the last little bit, minutes later he sets and rests for a while. So the last little bit has to be flatlined. So you know it's going to be that one, or that one. And then you think, okay, he sees a snake and changes direction. Which one changes direction? Well, it can't be this one. That one never changes direction. That one never changes direction. So just reading two of the examples tells you, right? Why can't they ever just give a normal name? Like Kiko? I've never met a Kiko. Does anyone else know a Kiko? Or is it Kaiko?
Is Kiko a boy or girl name?
I don't know. Is it Kaiko? Kaiko. So how do you say it?
Geico. It's Geico.
Keiko. Keiko is driving at a constant speed. Constant is driving at a constant speed. She then slows down to pass an accident. After passing it, she goes back to her original speed. So which one is it?
D.
It's definitely D. This is very easy. Watch. Keiko is driving at a constant speed. If speed is the y-axis, that one doesn't start off constant, that one doesn't start off constant, that one doesn't start off constant. Without reading anything else, I knew the answer was going to be D. Because D starts off constant. Okay? Any questions on those? That's it. Sorry about messing up, Donna. Look at that.